Hello and welcome to 6.3 Volumes About a Line. This is AP Calculus BC. My name is Mr. Green, your teacher. Today we're going to talk about volumes of solids that are being rotated but not rotated around the x or y axis. They're going to be rotated around random other horizontal or vertical lines. It's going to be great. But there's a prerequisite that we have to think about, and I know this is super basic. Bear with me for just a minute. We're going to talk about it. The length of a radius must be positive. That's where we're going with this. Okay, so here's a warm-up. Very difficult questions coming your way. Find the length or distance of the following. So I'd like you to try all of question 1A, 1B, and 1C. Have fun. I'll be back with my answers. Go. Oh, so that was super difficult. I got 4, 10, and 30. So basically, there's a pattern going on here. Let's talk about what that pattern was. For any two real numbers, A and B, where A is the bigger one, and I guess it could be equal to each other too, which of the following will give you the distance between them? So the bigger one minus the smaller one, or the smaller one minus the bigger one? You're probably screaming at your computer being like, Mr. Green, it's the first one, obviously. Duh, we know this since first grade. I know. But there's a reason I wanted to do this. We're going to do that with functions in just a minute. So let's apply this idea to functions, okay? And it's not this one because this gave us a negative number, right? And the distances are positive. What is the vertical distance between any point on the function f of x and the horizontal line y equals 2? So the key being vertical distance here, that's what we're going for. And if I was going to draw this, it would look something like this. And so our goal is to figure out the distance, the vertical distance from any point to this line. For example, this distance, and this distance, and this distance, and this distance. Kind of looks like a waterfall. We want a function that'll describe that. And the way that I could do it is I could just take the bigger one and subtract out the smaller one. So in this case, I could do x squared plus 6 minus the smaller one is y equals 2. So the distance would just be x squared plus 4. And that's it. That would tell us the distance between these two lines at any point. Like if I plugged in 1, I could figure out that it's 1, 2, 3, 4, 5. Yeah, see, it worked. Now, I'd like you guys to try it with this question. You don't have to draw a picture, but I think it's helpful to, so try it out. I'll be back with my answer soon. All right, so now I'm back. And I drew a nice picture, and what I did is I found the distance between the higher one and the lower one. And then I just subtracted them, so I did 2 minus negative x squared, and so the distance is just x squared plus 2. And I thought that looked pretty nice. And it works, so we can like plug in 1. We know that distance is 3. 1 plus 2 is 3, so it worked. That's wonderful. We're going to be using this exact same principle today when we're revolving things. So we're ready to find the radii of solids of revolution around a line. Remember, you're always going to do the top minus the bottom, or you could always say like the bigger minus the smaller one. See how I did top minus the bottom, or the bigger minus the smaller. I kind of don't like to say top minus bottom because when you rotate it around vertical lines, it doesn't quite make sense. But let's do a question together, and then I'll have you guys try a question. Let the region R be enclosed by the function f of x equals square root of x, the horizontal line y equals at 1, and the y-axis. Find the volume of the solid generated when the region R is revolved about the line y equals 1. Round your answer to the nearest thousandths. Okay, I'm going to graph it. I'll be right back. Okay, now I've got it graphed on here. I made 4 tick marks, 1, so that I can kind of see it. If I just did 1 tick mark, it'd be really, really tiny. But we've got to rotate this, and we've got to rotate it around this line, y equals 1. So the shape that we're going to have is going to look something like this. And choo, choo, choo. And I'm not a great artist, but I think I did a pretty good job on that one. And so we got to figure out the radius of that thing. And so to figure out the radius of that, we're going to need to know this horizontal distance here. And so the radius will just be the top one minus the bottom one. So it'll be 1 minus the square root of x. And then we can learn what we learned last time, that the area, I wanted to say volume, but I said area. I always do that for some reason. the volume is just equal to pi times the integral from a to b of the radius squared dx, or whatever you're using. So that's what we're going to be using. And we have everything we need to do, so we can figure it out by just plugging it in. The volume is equal to pi. I do not have a and b. Luckily, I know that square root of x just starts at 0 and 1. If I didn't know that, I could use technology, or I could set the two equations equal to each other and figure that out. But you know that by now because you've been practicing quite a bit with these. All right, so that's what we've got. I'm going to go ahead and figure out that integral, and I'll be right back. You want to try it too? All right, so I did it. I noticed that my question said round to the nearest thousandth, and remember it goes tenth, hundredth, thousandth, so that's 3 decimal places, just like the AP tests. And so I could just use my calculator to do it. I could have done it by hand, but you know, we got a calculator, might as well use this thing. All right, now I have a very similar question for you right here. I'd like you guys to try this question, and I will come back with my answer in a minute. Go. Well, I was about to do this question, and I realized I typed it incorrectly. Holy smokes. Y equals -4 revolved around 1. None of this is making any sense. Let's change this question here. I think what I did is I typed this one wrong and this one wrong, so let's change those and it'll make more sense. Let's take this one and change it with this one. Then it'll make more sense. Okay, try the question now. Alright, I changed my mind about everything. I want to do this with you because it turned out to be a little bit more complicated than I anticipated when I changed those things on accident. So if you look at this, I actually have 2 radiuses. I have this one, and I have this little radius right here that I'm going to have to subtract out, because when these things wrap all the way around here, it's going to create a giant thingamajig, and this -4 is not even in the right spot. So what I'm going to do first is I'm going to find the big radius. The big radius is this one, so it'll be 1 minus -4. So we'll say 1 minus -4. So the big radius is 5. Now the little radius will be the upper one here, which is square root of x minus -4. So what we're going to integrate is this thing from 0 to 1, and then we'll have 5 minus this thing. So give me a second, and I will write that all out. Now, the tricky part is, remember that you need to have a squared here and a squared here. So it'll be pi r squared minus pi r squared. And we can just shove that in the calculator to get the answer. All right, so that was a trickier question than I anticipated. Sorry about that. Let's try another one. So let's see if you guys can set this one up. I'll be right back with my setup. This one's a little bit more difficult because it says enclosed by these 2 functions. I'll be there soon. Can't believe I made so many mistakes typing this. I thought these notes were perfect when I typed them up. This should have been x to the 1/3. Holy smokes. All right, now it'll be doable. All right, so I drew a beautiful picture. X to the 1/3 looks like this. Square root of x looks like that. And so my big radius is from here to here. My little radius is this one. So I had to subtract that portion out when I find the volume of the solid of revolution. And this is what I get. We'll shove that in the calculator. Has anybody spotted my mistake yet? Here it is. Look at it. I have the wrong graphs. Take that. So this is the graph of x to the 3. Not the graph of x to the 1/3. That was my apologies, my apologies. Let's go back and fix it. So that means these are actually backwards. I'm going to fix everything. All right, fixing all of that gave me an answer of 2.827. Holy cow, that was a tricky one. Those graphs, you got to graph them. A lot of the graphs I'll just give to you, but not all of them. So you need to be able to recognize which one's on top and which one's on bottom. Don't do what I did and just graph whatever you feel like. Okay, let's try the next one. Go ahead and see if you can try to set this one up. This one's a little bit trickier because you're going to have to solve for where they intersect. Okay, have fun. All right, what a great setup right here. Now, you're probably wondering, Mr. Green, where did you get a root 2? Why is that a root 2? So what I did is I put them both into my graph, and then I pressed second trace, and then I went down to 5, which is intersect. And then it asks you what two curves are you intersecting, first curve, second curve, and then you guess. And then I got 1.414, etc. What that is just this root 2. I think. Let's double check. Yeah. Or the other thing we can do is we can press trace and second trace and value, and we can plug in root 2 to see if they're the same. If they're not the same, then I have to just use that crazy decimal that I had there. Yeah, they're the same. You can switch between functions by pressing up and down. Left and right moves the cursor. Anyway, that's what I got. So now we just shove that in the calculator, get the answer. Go for it. All right, putting that in the calculator, I got 37.212. I had to adjust the squareds, which makes me wonder if I typed another one in wrong, and I just didn't double check. If this is an A/B test, I definitely would have double checked. But on these videos, you could tell me if I'm wrong, so I didn't double check all that much. Okay, one last question. This one's a little bit harder because it's in terms of x equals. But it's the exact same strategy. You'll see. It's going to be great. So what I'd like you guys to do is go ahead and try out this question. The volume of the solid obtained by rotating the region x equals 6 minus y squared and x equals negative y about the line x equals 9 round to the nearest thousandth. So another calculator question. Go ahead and draw it. Oh, one thing I should say about this sketch right here is this was a pretty rough sketch. Like I definitely didn't have all the details in there. I had my calculator for that. But I just gave you a quick rough sketch because I thought, oh, I don't want to draw it very good. Another thing that I wanted to show you is this isn't the same question that we just did. This is a very similar question, but when you guys do your practice, I wanted to show you how these accumulate. So this is a function that we're going to rotate around this line, and if you drag this, this is what the three-dimensional solid will look like. And it's really hard to visualize these for me sometimes, but I thought this was a great representation of these. So play with the slider on Delta Math. You'll love it. And let's have you guys try this question right here. I will be back with my setup soon. All right, so that was a crazy setup. So I drew the picture, and then this rainbow color thing is the thing that we're going to rotate. And when we rotate that thing, it's going to be this beautiful shape that goes around like that. It's going to be pretty crazy looking. So my bigger radius is 9 minus negative y, and my smaller radius is 9 minus 6 minus y squared. And you simplify that all down, and then we can just shove it in your calculator. Another thing that was difficult is I had to find the bounds of integration. I got -2 and 3, and the way I did it is I just set these equal to each other. I could have used my calculator, but I chose questions on the notes that had good numbers. Sorry about that. Okay, now I'm going to shove this in the calculator and get the answer. All right, so I got 916. I said 619. Holy smokes. Hopefully I typed that in the calculator right, but this is the answer I got. Notice I had to round up because there was an 8 here. So I'm going to double check that I typed things in the calculator right, but if that's basically the end of the lesson, your practice is on 6.3. 6.3 is on Delta Math. Have fun doing it. I know you will. You love it. Okay, talk to you later. Bye.